My name is Milind Kulkarni. I'm the head of wireless lab at InterDigital. We've been at the forefront of research, innovation, and standardization in wireless and video technology for over 50 years. Happy to be here.
Okay. Thanks for inviting. My name is Qingdu Li from Shanghai University for Science and Technology. I'm also the founder of Joint Up company. It's very nice to meet you here. 我是李清都，主要是上海理工大学，然后机器智能研究院，还有就是我们做了一款那个人形机器人公司，叫这个卓一德，那个机器人在那边，一会儿大家有兴趣可以去看一看啊，谢谢。
Very happy to be here. I'm Dr. Yeo Yang from Asia Info. I'm the CTO and Senior VP from Asia Info. Asia Info, in a nutshell, is China's largest telecom software company. We help the telcos to deploy and construct the telecom software infrastructure from 1G to 5G. Very happy to be here to share some our insights from Asia Info.
Thanks all of you. So let's start. So based on our speech, we all of us talk about the standardization issue. So first questions I want to kill about the standardization things. The first one is we talk about whatever. So 6G, we have the three typical scenarios. Including some integrated sensing, including satellites, including AI, including computing and data service. So the first, very simple, based on all these features will be increased the standardization complexity in 6G. How to address this? So should we consider traditional standardization paths or we consider some new paths like open source? What is your opinion? Yeah.
I think the opportunity for the new innovation comes when the solutions are discussed in a consensus fashion. And the way the standardization works is primarily all the stakeholders coming together and discussing what the problem statements are, trying to come up with the best solution to solve the problem. And I think when it comes to AI or NTN or integrated sensing and communications, that's what's happening. However, the approach for implementation could be different. Once the specification is designed by the 3GPP standards organization, each company, such as the Nokias or the Ericssons or the Qualcomms, have the capability to implement those standards in their own way, in a proprietary way, that can also make it, high performing. So although there is some space for open source where people can bring all their ideas, I think at the end of the day, the industry will evolve towards having some proprietary solution as well.
Thank you.
Okay, my turn. Okay, I think in 6G, the most application we're in the robot or humanoid robot, the robot in factory or in family. But we have a lot of things to do. I think the robot is open source and communication may be also open source. So many people can attract in this area, so we can upgrade the whole framework. Okay.
Yes, I have to admit the fact the complexity of the 6G is true coming to us, particularly in terms of the integrated sensing, AI, communication, and computing. I remember at the beginning, at the stage of R16 and 17, we start to discuss integrated sensing and communication. 1 to 2 years later, we add 2 more elements: integrated sensing, AI, computing, and communication. See, the word itself is longer and longer, which means the more elements and new technology are on the way to be introduced to the next generation of the network, particularly for the 6G. Definitely, number one feature, number one tech on the way for 6G is we call it ISAC square, integrated sensing, AI, computing, and communication. Probably number two is the LEO or NTN. But for this number one feature, it calls for the joint effort from 3GPP Run, 3GPP SA, and 3GPP, definitely also the other organizations to SDOs to collectively work together, including Open Run and also the latest AI Run Alliance. A lot of the groups from these SDOs started to collaborate and co-work together already. I foresee in the existing 18 and 19 more and more new features in terms of the integrated sensing, communication, computing, and AI are to be introduced and included in the next few specs, R18, R19. We don't need to wait until 6G commercial launch to have these new features GA or commercial launched. We definitely, this particular integrated sensing, AI, computing, and communication can be commercial launched in the phase of 5GA. Thank you.
Thank you. So I just want to, based on these questions, go to more dedicated things. For example, we talk about AI integrator for AI. For AI, is we of course should be go to the protocol stack or just implementation issue. How to integrate AI? AI is we call it IT technology. Also, how to make 6G can keep the progress of AI technology, or should be considered by standardization? Yeah.
That is an excellent question. Just about every booth here has demonstrations related to AI in some form or fashion. We talked about AI in the previous sessions by Xiaonan as well as Uli in terms of how AI is coming into the standards. The previous session also covered AI in 5G advanced point of view. The point I'm trying to make, though, is AI can be used in network in many different ways. AI has its place at the radio interface level. AI has its place at the protocol layer. AI has its place in core networks. AI has its place at the service layer. And all these AI, they can do different things. So if you break it down, you will see the conventional AI, which is trained and that can predict things that can be used for certain tasks. You can have generative AI, which can then generate some solutions for you. Or you could use AI agents, which can not only generate the solutions, but can also do the reasoning and make its own decisions. So depending on what type of AI you're deploying, what is its purpose, and where it's embedded, the approach for standardization could differ. In many cases, you have to understand how the model will be developed, where the model will be implemented, how the model will be trained, how will it be shared, what are the security issues around the data that's generated by the AI or the data used for AI. So all of those things require very careful study and specification by standards.
Okay, thank you. So, do you have some?
I'm not the expert in this field, but I have a suggestion. I think the safety is very important, especially in the future. AI can do many things. So the standard, maybe we can more concern the humanity in the future. But for use a few years ago, maybe the ChatGPT can do not much work to influence the humanoid human world, but or physical world. But with the embodied artificial intelligence, the robot with the AI can change the world, can interaction with the world. So the safety is more important. For example, in the family, you have a robot. Robot is as a camera and or can hearing everything in your home. So maybe you need to very carefully for this the safety things or the privacy. So I think we may be more concerned this part. Okay.
So I'd like to answer this question with two folds, hardware-wise and software-wise. Definitely, if you want to integrate the AI into the hardware infrastructure, for example, those base stations and the different kinds of the network infrastructure, the next step is what? It's definitely you want to include and integrate the GPU, AI computing resources, join the party of the network infrastructure, which means in the future, in each G node B or in each 6G base stations, these AI native computing resources in terms of different types of the AI hardware is going to be a part of our network infrastructure. That is for the hardware. Software-wise, I still want to split it into the protocol stacks and also the AI applications. Protocol stack-wise, like InterDigital and some other, Qualcomm, the CT vendors, definitely we are open to discuss if there is a need to integrate the AI very closely to the radio interface, particularly for the 6G. I think InterDigital is also actively, joining this party in 3GPP. That is for the protocol stack. AI application-wise, so different kinds of the AI protocols and applications, particularly for these new AI applications connection functionalities. Now recently we introduced like A2A, MCP, those new AI agent-related protocols in the software stack. All these AI-related protocol stacks are still on layer 7. It is still built on top of the TCP/IP protocol. So for these AI application-related protocol stacks in the future for the software and applications, I foresee is still, on top of the legacy TCP/IP protocol stack. So probably that is the future for the software, that we how to integrate the AI in terms of these different rules and protocol stacks, still on top of the TCP/IP protocols. That's my point.
Okay. Thank you for feedback. So I think because of our mobile communication history, I think this is the first time so broad, like ICDT integration, integrate so many things. Besides the traditional 3GPP, we should consider more efficient way to make our standardization more efficiently to keep the future growth. So, okay. After 6G standardization, we can talk about 6G technologies. So based on our previous two speakers, they have already listed some like 6G components. But actually, I did not see some new names like traditional, how to say, like modulation, coding, and waveform, and some of these new names. What is your opinion? So in 60 times, whether or not we will generate some this kind of new names, like for what? CDMA, OFDM, what, yeah.
Yeah, that's a very interesting question. I think in terms of the technologies that we use to develop mobile networks, some of those fundamental technologies don't really change that much. When you talk about modulation schemes or the waveforms or the coding, that will continue to exist. That won't really change. But one of the things that is changing is, for example, in 4G to 5G, we put a lot of emphasis on how to do the spectrum sharing and we call that dynamic spectrum sharing. And that is basically the principle behind that is using the same frequency for 4G systems as well as the 5G systems. Now, in 6G, we are using a terminology called MRSS instead of DSS, which stands for multi-radio spectrum sharing. The concept is very similar, where the 5G and the 6G frequencies would be allowed to share. But those are the type of things you will hear about. Certainly, people referenced ISAC, so I'm not sure if everybody is familiar with that. But ISAC really stands for integrating sensing network and communication network together. All along from 2G until 5G, we've been developing communication network, and the sensing networks or the radar-like sensing capability that exists in communication network because we have antennas at the base station, because you have antennas in your smartphones, that was never capitalized on. So now in 6G, they are coming together, and we are calling a new terminology called ISAC. So those are a couple of examples of what new things are coming or how things are changing.
Okay, good. Thank you.
No.
All right, thank you for the opportunity. Definitely,
I'm not a person in this
I
field.
have to say, Milind just now addressed very interesting new topics such as ISAC already. That
Yes,
that
yes.
exactly what I was about to discuss just now. But that's not a problem. Definitely, ISAC itself is going to be a new concept to be introduced to 6G in the future. If you stop by our booths, you will see ISAC G-Node B base station over there, in which the sensing capabilities are closely integrated with the communication. If you stand behind the G-Node B in our booth, our G-Node B can detect your heartbeat, it detects your temperature, all these sensing, capabilities and features are on the way to be introduced to the next generation of the radio network infrastructure. That is very interesting. But at the end of the day, I have to say one vertical and one horizontal. One vertical, new concept is going to be the land network in the 6G phase is going to be interconnected with the LEO along with these satellite networks vertically. Horizontal-wise, it is ISAC. Beyond the traditional communication, we will introduce what? Sensing, computing, and AI. So ISAC can be expanded to ISAC square, integrated sensing, AI, computing, that is CPU computing, and communication. So I would suggest the new concept can be upgraded from the ISAC to ISAC square.
Yes, that's great. So why I ask these questions? Because I want to say we should open our mind. Because the traditional experts always think, this kind of new name, like CDMA, OFDM, Polo Code, and LDBC, this kind. So now these new times, this 6G is running to next generation. We should consider this new concept things, not just previous, this kind of old concept. Yeah, we should have the common understanding for this. Always challenged by some experts. So what is 6G? We need new names or not. So I think the new features, the new components is enough for 6G. We talk about 6G standardization and technology. So we can, next questions, we talk about 6G architecture issue. So each generation standardization, we always think about this. So 6G architecture point of view, we should overturn the 5G architecture completely or not. For example, we still talk about AI. So AI, we can go to embedding the protocol stack, or we can up to the application level. Because we always talk about want to make some terminal things or application things go to a network side. So always some like application he just keep in the cloud, he keeps the terminal. So the different way, What is the opening for this, for architecture design?
Yeah, so from architecture standpoint, I think It's quite straightforward in my mind. You know, Xiaonan already presented sort of some views from 3GPP in terms of what were some of the basic tenets they would use for 6G core design or 6G architecture, and it'll be based or it'll evolve from 5G architecture, because there's a lot of good things about 5G architecture that we want to continue to evolve into 6G architecture. And one of the things she referred to was a data architecture. And when you think about ISAC or when you think about AI, it will generate a lot of data, and it'll also use a lot of data. And therefore, the way we design the 6G architecture, it has to consider a data framework in a completely different way. How do you collect the data? How do you analyze the data? How do you store the data? What is the security aspects of that data? Is the data required for the network to improve the network? Or is the data required for applications, to run the applications? Or is the data being used to monetize and offer some commercial services? So there is a lot of questions and the ways you can handle the data. So I think establishing that data structure and the framework for data is going to be super important when we think about the architecture. Coming back to AI, once again, there are some other things we have to consider, such as much as we talk about introducing AI, at the end of the day, we have to think about how is that AI benefiting us? What problem is it trying to solve, and what do you gain? Because there is something you have to give to run the AI models. It requires computing sources, it requires power, it brings in some complexity. So once you get through all that and you're still convinced that AI brings in some gain that you can implement, then depending on what layer you're at, the implementation will differ.
Yeah.
And I think that's how the architecture will evolve based on the usage of that AI.
Okay, good.
I think in 6G, the architecture may be more complicated. From my point of view, I think, for example, in the factory, you need the communication. The data is much more. The communication must be very reliable. But in the road, there's a lot of cars also need the communication. The data is I think very large and also very reliable. And also in the humanoid robot, in different for service or something, there's a lot of sensors. The sensors, it's not like the data we used before. For example, I think for humanoid robots, not the vision, but also we have a touch sensor, force sensor, and every joint angles. Many stuff we need to communicate very reliably. So I think reliable is another thing we need to concern in the communication framework. Okay.
Okay. So long answer and a long question for short. If there is a need that 6G need to overturn the 5G architecture, yes, because the existing legacy network infrastructure way more than complicated. It's too much complicated. If you open up 3GPP network architecture map, there are more than 50 network elements defined from 2G to 5G, including the core networks and the radio networks. Is it need to be simplified? Definitely yes. Simplify the network architecture, simplify the numbers of the network elements, for sure. The follow-up question is if the AI need to be embedded in the protocol stack or the application layer, for both. Okay. Definitely, I think Milind just now explained why it is needed embedded into the protocol stacks. Yes, because these new capabilities like ISAC and NTN are to be introduced to the next generation of the networks. Accordingly, the protocol stacks is natively need to be integrated with these new features like AI and sensing. So yes, application layer also the third yes. Application-wise, those are the layer 7 applications in terms of AI agent and co-pilots. In the future, also needs to talk to each other, also need to be sitting on top of the layer 3, then layer 7. Definitely those new AI protocols also need to be sitting on top of the network protocol stacks.
Okay, thank you for this. So after our architecture issue, we still can consider service and application topic. So based on the current status, is there any real application or service to driving 6G standardization forward today?
Yeah, so, at InterDigital, we've been doing a lot of research and innovation on the wireless side as well as the video side and also AI for both of them. And one of the applications that we really like, that we think that is going to enhance quite a lot with 6G is immersive applications. So the way people watch video today, it still consumes a lot of bandwidth, there is more data that's required to make the video quality better. And then the user experiences, when the networks start to degrade, how do you take decisions to either do a little bit better compression or do a little improved quantization of the video images or do the network performance improvements so that the quality of experience for the user is better. So I think considering all of those and being quality aware network is very important to support these applications. So that is one of the things that we're focused on from a 6G point of view. So I think all of this comes together, especially when you start to watch sports and sports entertainment on your devices. So that is another area that we are very excited about.
Okay, good.
Okay.
You focus on embedded intelligence.
Okay, I still want to talking about embodied artificial intelligence. In the future, I think most device or the terminals of communication, the main not cell phone, most is on robot. For example, for the robot, Elon Musk predict that everyone maybe have 2 robots, one for life, one for work. Each one, the robot have as I just said, that have a lot of sensors. The sensors much beyond, much more than our cell phones. The robot also always works. Not a cell phone can just power off or do not work. But it needs a lot of data transform and latency, and also solve the reliable and privacy, safety. This thing we need to concern. But use 5G and 6G, it have a lot of good features, especially low latency, reliable, and more data bands. And in this way, for mobile robot, and it cannot carry a lot of powers. Batteries, also computing powers. We need to put the battery and put the computing power in the cloud. So there's three parts we need to solve the computing power. One is in the robot, I mean embodied artificial intelligence. It's a carry on in the robot. The second part is on the, I mean, in the edge side, means in the station. It's not far away from the robot. This kind of computing resource is not too much of computing powers, but it's much more than the mobile devices. But the third part is in the cloud computing. The cloud computing, we can have a lot of data and a lot of powers and also a lot of computing resources. So the three level of this kind of architecture maybe help our robot maybe longevity, that make a robot can work a more long time. For example, in recently you can see a lot of humanoid robots. They only can work no more than 1 hour. If you want a robot to serve a human, maybe serve a human or serve in some, I mean, in hotel or anything else, everything. The longevity is a very hard issue to solve. So in the 5G or 6G, we need to solve this kind of stuff. Maybe this is a good opportunity for us, especially for the applications. Okay.
Okay, yeah. Before we wrap up for lunch, and very quick 2 points. Number one, application that I foresee is the NTN. So the land network in 6G is going to be interconnected with the satellite network. For example, if we take on a plane in the future, you can feel free to use your cell phone, roaming and traveling, on the air to use the 6G network. That is number one, NTN. Number two is definitely the sensing for 6G, the ISAC or ISAC square. All these sensing related capabilities, like robot, like autonomous driving, are also going to be joining the party for 6G. So sensing related features and services are definitely required for 6G. These 2 quick points. Thank you.
Okay, thank you. I think the service and application is the source for 6G. It's related with architectural issue, standardization issue, technology issue. I think this is very important. I believe in the 6G, the new terminal, whatever new robot, new drone, new glass, and new AI phone, all AI agent will be changed all 6G things. So I think the last questions, just for maybe in 1 word, just to summary our panel. By 2030, when 6G business deployment, which industry should be changed mostly and why?
I always try to look back and see how Uber just came out of nowhere and disrupted the whole transportation industry. I think if we look ahead, it's hard to say which application will be another Uber-like application that will disrupt. But one thing that we are hopeful for is all the advances that we are bringing in mobile networks technology will create or enable various different types of devices that we can all use to help us, whether they're robots, whether they're glasses, just multiple of these devices that can help us serve better.
Okay, thank you.
I think in the future, I think we can see a lot of robots around us. It's a 人机共生的时代。
Okay.
For me, the telecom industry itself will be shifted, aggressively in 6G. Probably our industry is going to shrink down a little bit in terms of these new capabilities to be introduced into our industry itself, like AI, like automation. We don't need have so many, labors, extensive, services, very heavy network infrastructure. Everything in 6G phase might be simplified and shrinked, which is good for our industry, Thank you.
Great. So I think we will change the world. Our service should change the firstly. Yeah, our telecom industry maybe in the 2030s will be changed firstly. Yeah, that's great. So let's finish our panel discussion. Thank you for all of you, good thinking and sharing. So thanks for all audience to join us. So thank you. Thank you very much.